Hi, everyone. I apologize. Zoom was not letting me in. Oh, despite the fact that I am uh, the person that is supposed to be hosting the event. So I apologize for the delay in getting started. Um, we'll give it just a couple more minutes to see if anybody else joins. Um, let's see. Pull up my slides. So I guess good morning, everybody. I'm in Singapore right now. So for anybody on this side of the world that might be joining in, I appreciate that because it's 7 a.m. for us. Go share screen. Right. Okay, well, I guess we'll go ahead and get going. Um, so greetings from the Material Science Department at UC Berkeley. Um, I'll give you a brief introduction to me. So I'm the person, the director, I forget, lead, I guess is what the College of Engineering calls me for the Masters of Engineering program for Material Science and Engineering. Um, I got the job when I moved from University of Illinois Urbana-Champaign to Berkeley in I guess the summer of 2014, 2013, 2014, something like that. Because I had started the master's program while I was at UIUC. And so our current dean and then chair, Mark Astor, was like, you're the perfect person to run our master's program. So I've been running the MEng program for materials science for at least a dozen years. And let's get that up just in case. And so I have set up many of the rules and policies and whatnot. So I should be able to answer any questions you have. There's somebody like me for each department, and we meet once a month to discuss and see how we might improve the Masters of Engineering program. And so this is a college wide effort. It's hosted out of the Fung Institute. So you essentially have two different organizations to help you. And so for the technical aspect of the program, that is me and the rest of the material science folks. For the what I call the mini MBA aspect of the program, we have Fung Institute. And so they house all of the MEng students, so electrical engineering, mechanical, civil, material science, and whatnot. Um, and then Fung is the has staff members to help you find jobs and all the things like that. Um, okay, so that's kind of who I am and what I do. I guess so. I'm in Singapore because I'm also CEO and director of the University of California Research Center here in Singapore. So I split time between Berkeley and Singapore. see. Okay, so we can get going on here. Okay, so that's me um, on the left. Um, on the right is a brand new staff member, Temple. Oh, shoot, I screwed up when I was doing the slides last night. That is not Temple's email. I'll make a correction to this, but you can find Temple. So Julia used to be um, our grad student person in the department. We have hired Temple, um, who we're thrilled to have. And so I know the phone number is correct, the office is correct. I just forgot to correct the email address last night. And so really inside, right? So we have Fung in the department. So Fung can help with lots of the programmatic stuff. Um, I'm there specifically for the technical, and we'll go through lots of this stuff. And Temple will really be a resource for you to navigate the bureaucracy. Um, One of the great things about Berkeley is it's big and you have lots of opportunities depending on what your interests are. So we get folks from physics and chemistry and chemical engineering and biology and mechanical engineering and whatnot that would like to get their master's in material science. Well, it turns out that we have lots of highly ranked programs and they bring in lots of really interesting people. And so, if you're coming from a chemistry background, maybe you're going over and hearing people in chemistry, world famous chemists who are on the material side, visiting campus, speaking and meeting with them. And so there's lots and lots of opportunities for you to be involved in different activities, different programs, and what have you on campus. But that also means that we are very large and very bureaucratic. And you can get lost in the bureaucracy. I know it happens to me from time to time. And so Temple is going to be a wonderful resource to when you have a bureaucratic question about, gee, I know it's past the official drop deadline, or okay, we just had a student that um, needed to transfer um, from chemistry to material science their graduate research units. And so they came under me for their graduate research units, and then Temple helped us navigate the bureaucracy to make that happen. So we're very fortunate Temple joined the department, and she will be a wonderful resource for you. Um, okay, and so we're the two main contacts in the department, myself and Temple, but there are all the staff members are very helpful. And I'll get back to stuff about the department in a moment. Just kind of historically, and when you get to campus, if you get to campus in the fall, the building here on the left actually still is there. Um, right. So this red brick building is still there. Um, the white building has been torn down, and I think that's actually where one of our library, the main, I think, Doe library sits now. But this is what Berkeley, the university, looked like. And so these were the first two colleges, mechanical arts or mechanical engineering and civil engineering. Um, and then basically right here over kind of forefront to the right is where Hearst Mining Building is now. It was the third building on campus. Um, and it was introduced as the College of Mining. And so back here, if you look at the picture on the upper left, 1909, there's actually a mine shaft that goes back into the hillside. And there were small train tracks that led into the building, and where people would pull the stuff out of the mine and bring it in and process it and learn how to process ores. Um, so it is, I think it's the most beautiful building on campus, and it was the third building built on campus, and so it's the second oldest. Um, see, yeah, this is the lobby. So if you walk in the front doors, so you go up the steps and into the front doors, this is the lobby you enter. It really was modeled after the National Library in Paris. And so just down here at the bottom, where my pointer is, that's 210 Hearst Mining. And so all of the non-technical staff is housed in 210 Hearst Mining. So we have several technical staff members that handle labs and you know, educational programs. But then up here on the second floor um, is the student bay. And so the lobby is just outside these doors. And so we have a large student bay where grad students, postdocs, and then you as master students get to work. And so in the back, this is an old picture. We have, I don't know, 5 or 6 tables so you can have group meetings. And so one of the things you'll do is fill out an online form, and we'll get you access to the building so you can come in on nights and weekends. And then the student bay area is card keyed access, so you can go in and have group meetings in there, like I said, or study for homework or whatnot. And the majority of the classrooms that you'll take classes in, at least in MSE, are just right behind the student bay. So it really is the center for grad student life in the material science department. Um, right. And so this is kind of right. The campus is pretty large, right? We have roughly 32,000 students, 170 departments. And so it's a very large place. And so there's any large institution has lots of bureaucracy. And so that's where Temple and I come in. Um, uh, again, you know, I don't put too much weight in these rankings, but the thing I want you to take away from this is we have lots of highly ranked departments. And in a few slides, I'll bring this back to how this actually affects you as a student in material science um, in terms of class selection. All right. So we've got lots of really fabulous faculty in and throughout the College of Engineering. Um, so the point that, I just said that we have about 32,000 students between grads and undergrads in the university. The department is very small in comparison. So in terms of engineering, I think only nuclear engineering is smaller than us. In terms of campus, we are on the small side for campus. So, roughly speaking, we have about 300 total students in the department. It's about a 50-50 split between undergrads and grad students. And so, while we are in this large university, right? Material science is a small department. And so you actually get to know people. You see the same people in your classes. You can get time to know the faculty members, and get to know the other grad students, PhDs, postdocs, right? And what have you. And so I think this really is kind of the best of both worlds, at least from a student perspective, is that we are a small department that offers lots of personal attention because we're small, while getting lots of the access to lots of the things that much larger campuses offer, right? And so just I think I could be wrong. I'm trying to think if there's any other active folks in the department, but I might be the only person in the department that does not have an affiliation with Lawrence Berkeley National Lab. And so, if you're not familiar with this, right behind campus is Lawrence Berkeley National Lab. Um, I used to have an affiliation, but when I became CEO of the research center in Singapore and started spending lots of time outside the US, in fact, roughly about half my time is spent outside the US, this introduced lots of reporting requirements on me because Lawrence Berkeley Lab is obviously a U.S. institution from the Department of Energy. And I had to start reporting where I was traveling, who I was meeting with, and I was getting very little money from LBNL at that point. And so the reporting for me became more onerous than the money that I was getting from LBL. So I turned in my badge. Um, but the vast majority, if not everybody in the department, has an affiliation with LBL. We have several faculty members that are adjuncts, so they're really LBL staff scientists who are in the materials area, and we have them as adjuncts because they offer uh, very interesting classes at the graduate level that we otherwise wouldn't be able to offer, such as Joel Ager, who will be teaching MSE 242 in the fall, which is an advanced characterization class. And Joel is an expert on semiconductors and semiconducting materials and catalysts, um, and so he teaches a class that we otherwise would not be able to offer at the graduate student level. And in the past, we've had Miguel Salmeron, who is a expert on surfaces, and he teaches a surface class for us. So, along with resulting in significant research expenditures from faculty, the access to LBL helps us improve our courses that we offer. And so these are just some of the facilities that you may gain access to. So just up on the upper right is, this is a bit older picture, but Peter Hoseman in nuclear engineering is seated. Andy Miner is in the blue shirt. Andy's the director of the National Center for Electron Microscopy up at LBL. And so we've had students in all of our groups that, while doing the Masters of Engineering program, did research projects with Andy, Peter, and I've had students do it with me. And in fact, one of my current PhD students was an MEng student who did research with me while he was a MEng student. And so Andy hosted, well, the first student in our Master's of Engineering program, Rupan, who worked for Andy while he was a Master's of Engineering student up at LBNL. And then Andy accepted him in his group for a PhD. Um, so there's lots of resources. If you're interested in research, LBNL is an additional option to look for folks that do work that you're interested in, but also on campus, we have the Marvell NanoFab laboratory, right? And so there's lots of opportunities to be involved in other activities on campus. Okay, so now kind of to the meat and potatoes of the program today, right? Curriculum and the program. So this is and I will send out, I've written up kind of a 1-page front and back guide to the Masters of Engineering program that we generally send out in the summer once we know who's coming and whatnot. Right. And so you have the boot camps, right? For material science, right? We get, as I pointed out earlier, we get many students from, say, a physics, chemical engineering, chemistry, biology, or mechanical engineering, or what have you, backgrounds that are not from material science. So we technically require MSE 200. And MSE 200, the idea is what material scientists do different than other people that work on materials is we tend to really care about the structure properties relationship. So how do I modify a material to get a structure that results in the properties I want? And that has been traditionally how material science has operated. Now with AI, lots of people on Earth, including me and my program here in Singapore, are looking at the inverse design problem. How do we start with properties, and can AI design the material in terms of structure that will give us those properties? But so MSE 200 is a introduction to material science at the graduate level, and it covers most aspects of material science, but really gives you that foundation such that for example, we've had a number of Masters of Engineering students that have gone on and worked for Apple. Well, Apple's going to ask you a question about structure properties in the interview. And if you can't answer it, they're going to wonder how you got a material science degree from Berkeley. So if you do not have a material science undergraduate degree, you will be required to take 200. If you have a material science and engineering undergraduate degree, you would send me an email. I will look at your transcript and then just say, oh, yes, you can waive this. And so that would allow you to replace 200 with another graduate level course. So at Berkeley, 0 to 199 are undergrad, and 200 to 299 are graduate courses. Okay, so then we just have another MSE 200 class. Then we have another MSE 200 class. But this is what I was pointing out when I said it was very nice that we had lots of departments that were very well regarded and lots of faculty that were doing incredible stuff. One of the things I did a couple years ago was went to the faculty in a faculty meeting, and I asked them to vote on letting you, the student, take one class from outside of MSE and have that count towards your degree. So I did this multiple times every year. I had to write up cases and get the academic affairs committee that oversees graduate students and meet with them and present cases through to get approval for the student to take a class outside. And I can give you an exact example of this. We had a student that was working for Applied Materials, um, was working on plasma processing of materials, and wanted to take a nuclear engineering course that was a very advanced course on plasmas. And so I had to make the case that the student should be allowed to take this class because it was clearly appropriate for his desired outcomes from the program. And so I was doing this a lot, and it was a lot of work for me, and it was a lot of work for the chair of the academic affairs committee. And then if you look at all the departments, they all have materials related courses, right? With their specific slant on materials or specific areas of materials that they are interested in. And so what we did as a department, and it was a unanimous vote once I made the case, was that you have to have 12 units of 200 level classes. One of those classes may be taken from another engineering department, right? So it could be chemical engineering, mechanical engineering, and I've got a list on the next slide that we'll talk about. So if all the classes are 3 units, you would take 3 MSE courses and 1 class. If all the classes are 4 units, you would take 2 4-unit MSE courses and 1 4-unit from outside. And the idea is this gives you significant flexibility in designing your curriculum, technical curriculum, to meet your desired outcomes of the program. Okay. And as far as I know, we're the only MEng program in the college that did this. So the best place to go for information about classes is classes.berkeley.edu. It will be the most updated website with course information. Very typical program that is offered in the fall may look something like this, right? MSE 201A, thermodynamics. It really is designed for PhD research stuff. So I said very hard. It is very hard. And the person that teaches it thinks it should be very hard. So I've had MEng students take it. But if you're not going to go into research, I think there's probably better uses of your classes. Again, spring, and note that I didn't update this last night. This is the general courses. So I think if you look for the fall and you look at classes.berkeley.edu, you'll find MSE 242 taught by Joel Eger, which is advanced characterization techniques. The spring MSE 201B is a continuation of 201A, and 202 is really lots of quantum mechanics and different ways to model crystal structure and bonding. If you want to take them, I don't have a problem with it. They just tend not to be so industry relevant. So all 3 classes I marked as very hard. The content is difficult, but they tend not to be so industry relevant. They tend to be very research relevant. So these are 3 courses that all of my PhD students end up taking because, so I'm a computational modeling person. And so these are all courses that my students take because it really is required for the research that they do. the MEng students that I advise and when I run capstones, I recommend they do not take these unless there's a specific reason. Um, and so, you know, the other side of allowing you to take a class from a different engineering department is we're a fairly small department. I think we're about 18 faculty now. We have undergraduate courses to offer every semester. We have graduate courses to offer every semester. So this means we're not going to be offering 20 graduate level engineering courses in the department. We just don't have enough people to do that. And so allowing you to take a class outside of MSE, again, in addition to allowing you to tailor your program, it opens up areas where you might want to take a class that we just don't have the staffing to offer. And so this is, again, bioengineering, civil and environmental engineering, mechanical, nuclear, industrial engineering, operations research, electrical and computer science. Chemical and biomolecular engineering is actually in the College of Engineering, or sorry, is in the College of Chemistry. But if you wanted to take a chemi class, we would count that. Okay, so up here at the top, there's engineering. If you go to classes.berkeley.edu, you will find classes that are not specifically hosted by any department. They are courses that are offered because we think they cut across all of the departments. And so they are listed as engineering. I think there was engineering 261A, 261B, which was really applied mathematics for, graduate level engineering type thing. I believe SET, the Sutarja Center for Entrepreneurship and Technology, all of their courses are listed as engineering. So if you find a 200 level course that's engineering and doesn't seem to be assigned to a department, that would still qualify because it's a graduate level course in the College of Engineering. Again, you may take one course and from any of these and have it count towards your degree. It must be taken for a letter grade. And again, the idea is this offers you flexibility in designing your curriculum to best suit your desired outcomes from the program. Okay, there's a comprehensive exam. It is really based off 200A. So when I rewrote it, Ji Yoon Kang teaches 200A. I shared with her the 20 question multiple choice short answer exam to make sure that she covered the material in the course and she thought it was appropriate. So if you opt out of 200A, that means you have a solid foundation of material science. We believe that you understand the content in 200A. So, for example, there are 4 sections of the exam, 5 questions each. And so there are 5 questions on electrical properties of materials. There are 5 questions on phase diagrams. There's 5 questions on bonding and crystal structure. There's 5 questions on mechanical properties. If you've had an undergraduate degree in material science, you have taken a semester-long or quarter-long class in each one of these areas, in addition to an introductory class in 200, similar to 200, just at the undergrad level. So you should be fine. If you fail the exam, For the fall semester, you get to retake it in the spring. You get 2 shots at it, so it shouldn't stress you out too much. Uh, the capstone projects, there are multiples. I have to send an email to Rio Tinto, a mining company, about. I met with them. I was the person that led the charge, and we're part of a 5 campus, $150 million research program with Rio Tinto, and we're going to hopefully be able to offer some Masters of Engineering programs that would be um, supported by Rio Tinto, some materials processing or whatnot. This is one of the capstones I offered in the past with Eris Composites. So there are many, many, many capstones, right? I forget what we had last year, but it was over 100 capstones that were offered, I believe. Um, Again, material science being a small department, you may not find a capstone in material science that really suits your desires. That's fine. So, for example, we had a student that was really a biomaterials person, and due to multiple reasons, sabbaticals and folks becoming chairs of departments and whatnot, we did not have a bioengineering project that interested the student. And so she found faculty in bioengineering that were having projects that she was really interested in. And so I just looked at the project and said, oh, yeah, this is fine. You'll have materials. There's a materials component to this. You can write that 2 pages of your final report. And, you know, I can justify giving you a material science master's because you had a materials component to your capstone. We've been doing this almost since I took over the program, I think. And only once have I turned down a student's preferred project. And she wanted to work on, essentially, it was a faculty member in IOR who was doing fintech, and it really was a coding and optimization problem in finance. And I was like, sorry, um, I can't approve that one because there is no material science in the project. But other than that one, I don't think I've not allowed a student to go after the projects that they were interested in. You know, you applied to a material science program. I assume you're interested in materials and want to get better at materials. And so it's pretty much self-selecting. Um, yeah, so this just says what I just said, right? Just email me what capstones you're interested in. I get the long list. And generally, just me seeing who the faculty member that is overseeing it is enough for me to approve it. So it is not some big, um, arduous process. We just want to make sure that at the end, when you write your report, which really is written for the Fung Institute, um, that if anybody questions it, we can say, look, there was a materials component. The student deserves a materials master's, and we don't run into any headaches down the line. Okay, so I went round and around with Lee Fleming, who was the founder and original director of the Fung Institute, and his director, Beth. They kept arguing that the program was so intense, students should not be allowed to be researchers or student instructors or doing anything else. Um, and so finally, they pulled the statistics and found that something like, it's been a few years now, but something like 65% of the students in the Masters of Engineering program were taking additional classes, and something like 45% were taking two or more. And so Lee and I met and discussed this, and he's like, "You were right. We got lots of students taking extra classes. How do we reward students that really want to do this?" And so we came up with the Tech Plus certificates. So Lee and I and Beth wrote all up the guidelines and everything and got the graduate division and campus to approve this. And so if you take two additional technical courses that do not count towards your core courses, right? So just say you take four MSE courses that are all 3 units, and you're going to count those to satisfy your core requirements. Well, if you take two additional courses um, that are off different lists, you can get a Tech Plus certificate. And so going through the graduate division, going through all of the approval processes that we went through, allowed us that this will actually get noted on your transcript, right? So it's not just some meaningless certificate. It actually is noted officially by UC Berkeley that you did this, and can be shown to the world. And so we did multiples of these. The two I wrote up were, one was for materials for biological medical applications. And there's a whole list of courses from bioengineering and material science that would satisfy this certificate. And then I wrote up, and that was written up, just to be fair. I wrote certificate one, I wrote up with Dorian Leitman, who was former chair of bioengineering, and then now bioengineering MEng lead. And then certificate two, the structural materials for nuclear applications, I wrote that up with Peter Hoseman, who you saw in a picture earlier. But then, depending on what maybe you're interested in materials, but you want them for nuclear applications or structural applications, but you're also interested in security. So you could take 4 courses that apply for your material science degree, or the material science aspects of your technical degree, and have those count for that. But then you could take 2 courses that are listed in nuclear security that I've got here listed as certificate 3, and get the nuclear security certificate, right? And so Lee Fleming, who I mentioned, he and I started these things. He founded and oversees the Center for Intellectual Property on campus. And so he runs a program on intellectual property and entrepreneurship. And so then there's, engineering, data science, control of robotics, right? And modeling and simulation of advanced manufacturing processes, which that one's largely in mechanical, I believe. So if you take 2 classes from any of these areas that you do not count towards your degree, you can apply for the Tech Plus certificate, and it would be officially noted on your transcripts and whatnot. And again, we did this because we found that over 40% of the students were taking 2 additional or more elective engineering courses. So we wanted students to have some options to be rewarded for this. Okay, so hopefully it's going to be welcome to Berkeley. And yeah, if you have any questions, please uh, shout them out. I'm sorry, I didn't have the chat open, so I don't know if okay, I just opened the chat. So, if you have questions, go ahead and unmute or type them in the chat. I'm happy to answer any questions you might have because I am sure I missed something no matter, what I do. I always miss something in these talks. So please fire away. Okay, so what if we take two extra technical courses, but they don't align with a pre-existing student? So no, there would not be a way to. So to get the certificates approved, we have to go through graduate division and all of the campus bureaucracy, and that process to get a new certificate approved would be longer than you are on campus. So sorry to say, we would not be able to create a new certificate just for you. I wish we could. I wish we could have a much more dynamic way to do this, but unfortunately, we would not be able to. So there's a question about comprehensive exam. So yes, you are required to take. So there's kind of four components to the program, right? There is the core MSE aspect. There's the core Fung aspect. And so those are all your courses. And as long as you have again, this was something we presented to the department faculty and they voted on this. As long as you keep a 3.0 GPA cumulative, so it doesn't have to be just in MSE, you will pass the courses aspect of the program. And we did this, it used to be 3.5. We voted to lower it because we want to encourage you to take, venture out and take a course that you may be interested in that might be on the harder side of things, right? But if you, struggle with the class and you pass the class, then you would be able to maintain your 3.0 and graduate, right? So we wanted to allow you as much flexibility again as we could. So then there is a Fung Institute, essentially a comprehensive exam that you have to pass. And then in material science, there is a comprehensive exam that you have to pass. Then there is the final thing is the capstone, right? So to satisfy the program, you have to have a 3.0 GPA. You have to pass the two exams and you have to do a capstone. And so it's not a either or with the capstone and comprehensive exam. It is a both. Okay, so how common is it for MEng, MSE students to do research? So I'll answer, is this as capstone or otherwise? So the capstone is a requirement of the program. So you have to do the capstone project. Thankfully, there's 100 or so different capstones, I believe, last time. So generally you can find something you're very interested in. Then if you want to do research, you go talk to faculty members. So I tend to do quite a bit of research on surfaces and catalysts and electrochemistry type stuff. And so my current grad student, Mark, came to me. He had a double major in physics and chemistry, wanted to transition into material science to be more applied. And he said, "Hey, I did some catalytic work as an undergrad. I want to continue that. Would you be willing to have me in your group?" And so we just talked. I go, "Okay, I've got this project. Do you know anything about these codes? He's like, yeah, I've played with them. I've ran some stuff. I was like, okay, then let's get you started doing research. So he did his capstone project and his research. Um, Rupon, who got his PhD with Andy Miner, did his capstone and his research, and just spent a significant amount of time up at LB&L doing work on the transmission electron microscopes, or TEMs. And I'm sure there are others, but I know Professor Wu, Zheng Chao, who's our current chair, um, has had, I know one, I think it's two former capstone students that have joined his research group for their PhDs. That is not the common path. We get maybe, I would say, 10-15% of the students, the MEng students in MSE, will do research. Um, we've had students that have gone and found internships. So while they're doing their capstone and coursework and whatnot, they've interned with startups, or, you know, with companies in Silicon Valley. And so we had one student that was essentially driving down to Applied Materials twice a week to do their internship, and they just scheduled everything around their internship. Right. So there's lots of opportunities for you to do other things. Research is generally not the common approach for masters of engineering students, but it's not insignificant if you're talking about roughly 15% of those in MSE doing research. Um, so yeah, you would do research in addition to the capstone. Um, and we can, if you have questions, we can delve more into the capstone, but there's like engineering 270. And so there are specific courses that you'll take at Fung that are geared towards the capstone that I do think are very valuable. So they teach you how to plan a project. So you learn planning, you learn presentation skills, writing skills. And so throughout the whole year, you'll start preparing your report. So at the end, essentially, you've had a year to write your report, and you basically turn it in, right? So there's a lot of soft skills, and I cannot stress enough how much speaking and writing affect your career, even in the age of Chat GPT. And I'm hiring a new postdoc, and right, the first thing I did was go to Chat GPT and had it write up a job description for me. But then I download that and I edit it, right? So even in the world of AI, right, having ability to write and is a good skill to have. Let's see. So I think that answered your question, Cole. Okay, so how does the class schedule plus requirements change if you're enrolled as a part? Oh yeah, great. So you had, yeah, so we've had a number, well, not a number, it's not a large number. I think we've had 3 part-time students in the material science program. And effectively, the first decision you make is whether you're going to do the capstone. So part-time program is a 2-year program instead of a 1-year program. And so then you kind of make your decision on when you want to do your capstone, in the first year or the second year. And then essentially you spread all of your coursework out of over 2 years. And so you may, in your second year, decide that all of your technical coursework will be your second year, and all of your leadership, mini MBA, and capstone projects will be your first year. And so I would be happy to meet with you and discuss this, and you know walk you through this. And in fact, we've got somebody doing it right now, and he'll be taking his I have to send him an email. He'll be taking his comprehensive exam now in year 2 instead of year 1, because he set up his program such that the coursework for MSE was in the second year. Um, yeah, so you have lots of flexibility as a part-time student, and I'm happy to help you figure out what might be the best approach for you. So is it common for MEng students to have teaching assistant positions? So we've had MEng students have teaching assistant positions. Now, the thing I will say is you will not get a teaching assistant position in the fall. And that's because we've essentially hired all of the teaching assistants we have. And so everything is unionized now in terms of graduate students. And so there's a timeline that we have to follow. So all of the folks for the fall have been hired or are in the process of being hired right now. And so there's no way for you to even get on the list to get hired in the fall. But certainly in the spring, you would have the option to put your name on the list on what you would like to teach. And this can include other departments. So, for example, physics has reached out to us in the past about not having enough TAs for their classes. And so our grad students that were qualified could apply and be a TA in physics. Right. So yeah, I've had MEng students TA for me. Yeah, I taught material science and engineering 45, which is kind of the freshman sophomore level introduction to material science, and I had a MEng student who had done his material science degree out of UCLA TA for me. So it's not the norm, but it certainly can happen. It just, there's no way. Well, okay, I won't say that because maybe faculty lose their TAs and stuff and they're looking for somebody at the last minute in the fall. But in general, it's very difficult for you as incoming students to TA in the fall just because of timelines. But in the spring, yes, you can absolutely apply for those positions and you will get put onto the grad student emailing list. And so you will get emails about, hey, if you're interested in TAing, go here and fill out the forms. So, yes. Is the comprehensive exam itself just pass? Yeah, it's pass, not pass. And so essentially, I grade it. I write it. Well, okay. In fairness, Professor Asta and Professor Sean and I wrote the original ones, and then I tweak it every year and change a couple questions. So then I will just start grading from the front. And right, there's 20 questions. If you get 12 points, you pass. And so I will just go through and start grading. And when I hit 12, I stop grading, right? Because you've passed. And so, yep. And so as long as you get 12 points, 60%, you pass, right? You can get 100%, right? Doesn't matter. There is no A, B, C, D on this. It's pass, fail. And in general, I send out a very detailed study guide for the comprehensive exam. And again, I will show the exam to Ji Kang, who teaches MSE 200, to make sure it's appropriate. And then after she reviews it and gives me the okay that, yeah, it's consistent with what she's teaching in 200, I will write up a rather detailed study guide and send it out. And the students that have followed that study guide um, have passed. Um, and I will, we've never had a student not, well, we've never had a student fail the comprehensive exam twice. So every student has graduate, or we've never had a student not graduate because of the comprehensive exam. Okay. So is it possible to, yeah, so it's absolutely possible to obtain a research position. Um, this is going to depend on the individual faculty, whether they have space in their group, um, and whatnot, right? So like me, I will be spending a significant amount of time in Singapore and other places. So I'm a terrible research advisor right now. You can talk to my current PhD students. Um, and so I probably will not take anybody, but there's a host of faculty that don't have my travel restrictions, right? Or aren't traveling like I am. And so yeah, and I'm trying to think. I think most of the faculty in the department at one point have had a master's of engineering student that do research with them. So it's something the faculty are open to. It's a faculty by faculty case. Um, okay, so do you recommend talking with you on which of the 7 technical concentrations? Sure, I'm happy to talk to you about the technical concentrations. I would be the one that would be able to best guide you on that. Filling out the paperwork and whatnot, that all lives with Fung. Um, but yeah, I would be happy to talk to you about the technical concentrations. Um, but again, you know, I've tried to get that removed. Um, you're free to do any of the technical concentrations. You're free to not do any of them, right? So your graduation does not depend on whether you satisfy those things in mechanical properties or electrical properties or what have you. Um, so the research for the capstone, I think you can get up to speed really quickly. Um, I do not I do not remember a case where there was a student that had difficulty with the capstone because they couldn't get up to speed. We've had difficulty with capstones because um, some of the capstones we traditionally take are from Cyclotron Road, which is the incubator at Lawrence Berkeley National Lab, and it's focused on energy. And we had students that applied and got accepted and were working on it. Then the folks wanted to come back and have NDAs and start putting all these restrictions on the students. And so we've had to be much more clear with industry partners about this. But I see the students getting up on, capstones very quickly. And so, yeah, I don't see a problem with that. The research aspects of it, depending on if you were doing capstone and you wanted to do research, right, that's going to be a case by case basis. Most of the time, the faculty will pair you with a graduate student or a postdoc. Um, Now, if you're coming in with research experience and you're find a professor that's doing lots of the same stuff, you may get a little more um, put in a position to lead a little more than you otherwise would have. But yeah, so my general rule is I can have undergrads or masters of engineering students in my group. Um, I can have N of those where N is the number of PhD or postdocs I have plus one. So I can generally advise or mentor a master's of engineering student or an undergrad in addition. So if I have 10 PhD and postdocs, well, that's 10. Me advising one would be 11, but that's roughly how this works. We talk to our PhD students and our postdocs saying, do you want to advise? And what project would the student work on? Uh, yeah. Yeah, no, okay. So follow up to the comp exam. Yeah, so you will be there will be two email lists. There will be the graduate email list that postdocs, PhD students, and master students are on that advises you of what's happening. So just Medina in the front office just sent out an email to the grad student list about financial literacy for grad students. So you would get that email. We will create another email list that will be just those of you that are MN students, and the comprehensive exam guides and anything I have to communicate to the MN students will get emailed out. And so every MN student will get the guide and get all relevant information off the MN specific um, email list. Okay. Um, this might be a minor question. That's fine. I have been reaching out. Oh, yeah. Okay. Yeah. So Amanda, uh, she is the department manager, recently hired. Thrilled to have her. Yeah, you can email me about this. Uh, just to be fair, I mentioned Medina just a minute ago. Um, and so as I mentioned earlier, we just hired Temple to handle graduate student matters. And we just had our PhD visit, and we're trying to finalize offers and get PhD students into the department. That would have been all Temple's job. And so right now, Amanda and Medina are filling in, covering grad students, PhD student admissions, and recruitment, and all of that. So it doesn't surprise me Amanda has not written back. I've sent her emails and she hasn't responded, but they were more informational. Um, she's very, very swamped right now, really kind of doing the job of three people, um, which this will stop shortly as new staff come online. But yeah, if you want to just send it to me. I will probably not have an opportunity to get to it till the weekend. Um, but I would be happy to respond to you over the weekend about any questions you have. Um, in another info session, someone said that the time commitment for MEng for fall semester is around 6 hours per week, while spring it's about 9 hours per week. That's yeah, so that's I don't know how they came up with that. The general rule is if you're taking a 3 unit class, you should expect to probably spend about 6 hours outside of class on that work. Now that's probably not completely true. I do think the spring, I also don't know what they're counting in this. So I'm going to be kind of broad here, Ethan, right? Um, so I would think that the spring is a little more intense than the fall. Um, and so why would that be? Well, you're trying to wrap up the capstone, you're trying to finish your report. Um, but in addition to that, you're also looking for a job, right? And doing interviews, right? And so there are lots of things going on in the spring that just weren't happening in the fall. And so I would not doubt that the spring is a little more, actually, I'm sure the spring is a little more intense, um, because you have lots of other things going on that are not just, gee, I'm have to go sit in on MSE 215 lecture now, right? You have other things that are going on, like wrapping up the capstone, like looking for a job, right? Or an internship or applying for OPT. There's lots and lots of stuff. And so, yeah, I would, whether it's 6 and 9 hours or 8 and 12, I don't really know, but there probably is 3 to 4 hours more in the spring for you to deal with than there is in the fall. Okay, I think I got just scrolling back through the questions to make sure I've answered them. Oh, right. So I go back. So I missed part of your. How long does it take to get trained or up to speed for conducting research? That's going to depend on the group. So I mentioned Rupon, who did his research with Andy Miner, and that meant Rupon had to get access to LBL, had to do all the LBL training, then had to do all the training on the TEMs, right? And so it takes a fair bit of time. And I know Rupon worked really hard, um, while he was, Andy got him in the lab while boot camp was still going on. And Rupon was doing lots of training at night and learning stuff at night. But even then, right, you're not going to put somebody in charge of $1 million microscope on day one. So it generally takes a little longer to get up to speed in, Andy's group than my group. I do computational research. And so, like, for the undergrad that just joined my group, um, essentially we designed systems for him to run. And so he started running stuff right away. And then the idea is he gets some results, can talk to us about the results, and then he can start designing his own system for this and explore that, space of structure properties relationship that we're interested in this problem. So, for him, it took us maybe a week, to get him accounts on the computers and get the computer systems to recognize him and then get him running. Um, so it really depends on, and I would say, so I'm probably at the extreme, or us computational people are probably at the extreme short end. Andy Miner and TEM and characterization is probably at the extreme long end. Um, but yeah, it probably takes a month to 2 months, depending on, for most experimental groups, for you to get trained, all the safety training you need, all of the equipment training you need, to really start being a functional member of the group. Okay, I think I got everybody's questions. If not, please retype them. Um, yeah. Yes. If there are no more questions, I'm not going to just speak at you. So feel free to log off. I'll stay here till everybody's gone. I know some people might be shy, and, um, yeah. Otherwise, thank you very much for attending. I will just go back here. If you have questions, you should feel free. there we go, to write me an email. And I will do my best to answer same day, but often it might not be till the weekend. So yeah, if there are questions that come up, please ping me. So does the MSE department provide support regarding connections? So the Fung Institute has a large effort to get you jobs. That being said, depending on what you're interested in, we may have connections. Um, Before I took over as CEO of the research center here in Singapore, I used to run a material science career day or recruitment or whatnot. And, I specifically got like Apple and Applied Materials and some startups and whatnot to come to campus and recruit material science students. And it was a great place for um, the MN students to look for jobs. Um, so we can help. My first instinct would be for you to go to Fung because they have, God, I think it's Jennifer, who oversees trying to get you interviews and help you find jobs. If you have specific questions about, local industry because, or Silicon Valley or whatnot, we have alums that like Nitosh works at Applied Materials. So we've had him talk to students. And so, yeah, and he was an MN student. And so, um, you know, where possible, I'm happy to put you in contact with former um, master students that are working in the area and, see where that goes. Okay. Well, we're approaching time. So, again, thank you everybody for showing up. If you have questions, um, feel free to email me. And yeah, I hope you all have a great day or evening, depending on where you are. And I hope to see you all in the fall.
Thank you. Have a good one.
Thanks. You too. Stop sharing.
Thank you.
My pleasure. There we go.